Hello everyone, welcome to Prevent a Solution given this nice algebra problem, which is 2 to power a plus 4 to power a plus 8 to power a. This is equal to 39. So what is the value of a? And given that a is a member of a real number. So now solution from here, we have that 2 to power a plus 4 to power a plus 8 to power a. This is equal to 39. The next step here, we can express 4 as 2 to power 2 raised to power a plus we can express 8 as 2 to power 3 raised to power a. This is equal to 39. And given the exponent property that 8 to power n raised to power m, this can be expressed as 8 to power m raised to power n. So let's apply this exponent property so that now we'll have 2 to power a plus 2 to power a squared plus 2 to power a cubed. This is equal to 39. Okay, so the next step here, we just say let 2 to power a being given as x. So let's substitute 2 to power a with x. So here we'll have x plus x to power 2 plus x cubed. This is equal to 39. The next step again here, this is x plus x to power 2 plus x to power 3. This is equal to, now 39 can be expressed basically as 3, okay, plus 9 plus 27. So let's take 3, 9 and 27 on the left hand side, so that we'll have x plus x squared plus x to power 3, subtract 3, subtract 9, subtract 27. This is equal to 0. Now the next step here, we can express this again as x plus x to power 2 plus x to power 3, subtract 3, subtract 9. We can express 9 as 3 to power 2, subtract 27 as 3 to power 3. We can express 27 as 3 to power 3. This is equal to 0. So now let's combine, that is, let's put this as x subtract 3, okay, plus, now we have x squared and 3 squared, so we'll have x squared subtract 3 squared, and then plus x to power 3 subtract 3 to power 3. This is equal to 0. Now here we have 3 parts. We have the first part here. This is the first part, and then we have the second part here, which is actually the difference of 2 squares expressed as a squared minus b squared, okay? And then the third part here is the difference of 2 cubes expressed as a cubed minus b cubed, okay? So now from what we have here, we have x. Now we have 3 parts here. The first part is x minus 3. The second part is x squared minus 3 squared, which is the difference of 2 squares expressed as a squared minus b squared, which is a plus b and a minus b. The third part is the difference of 2 cubes. Now we have x squared minus 3 squared, which we can express as x plus 3. And then this is x minus 3, okay? So let's call this one equation 1. Now we have the difference of 2 cubes expressed as a cubed minus b cubed, which we can express as a minus b, a squared, okay, plus ab plus b squared. So that now we have x to power 3 subtract 3 to power 3, which we can express as x minus 3, x squared plus 3x plus 3 squared, which is equal to 9. Let's call this equation 2. So let's combine equation 1 and 2 and the first part here. So we have the first part as x minus 3 plus equation 1, which is x plus 3, x minus 3 plus, now we have the equation 3, which is x minus 3 here we have x to power 2 plus 3x plus 9. This is equal to 0. The next step here, you realize that x minus 3 is common here in the 3 part. So let's factor out x minus 3. So that now we'll have, in the bracket here, we'll have 1. Okay? And then here we have x plus 3, x minus 3 divided by x minus 3. We'll have x plus 3. Okay? Plus, now here x minus 3, simplify here, so that we'll have here x squared plus 3x plus 9. This is equal to 0. Now here we have two parts. The first part is x subtract 3. This is equal to 0. And the second part here, we have x squared plus, now we have 3x plus x, which is actually 4x plus, this is 3 plus 9. This is 12. 12 plus 1. And this is equal to 13. This is equal to 0. Now we have two parts here. The first part here, x minus 3 is equal to 0. So that means that x is equal to 3. And this is a real solution. This is a real solution. And the second part here is a quadratic equation of the form ax squared plus bx plus c. This is equal to 0. Now, this quadratic equation, we have the value of a equal to 1, the value of b equal to 4, and the value of c equal to 13. Now, let's check the nature of this quadratic equation by assessing the discriminant value, which is basically b squared minus 4 multiplied by a multiplied by c. So let's substitute the value of a, b, and c. So here you have 4 squared minus 4 times 1 times c, which is 13. So 4 squared, this is equal to 16. Subtract 4 times 13, which is essentially equal to 52. So we have 16 subtract 52. Now we have 16 minus 52, which is actually equal to negative 36, which is less than 0. So in this case, that means that here we'll have no real solution. In fact, here we have two complex roots. But if you recall, we end the condition that a is a member of real numbers. A is a member of real numbers. So from here, the quadratic equation in this sense is rejected. So now that means that we have only one real solution here, which is x is equal to 3. Now, if you recall, we have seen that let 2 to power a be equal to x. Okay? This is from this part. So that now, substituting the value of x here, we'll have 2 to power a, this is equal to 3. To solve for the value of a, we introduce the natural logarithm on both sides. So we have log 2 to power a, this is equal to log 3. So log 2 to power a, this is in the form of log a to power n, which we can express as n log a. So applying this power rule property, we'll have that log 2 to power a as a log 2, this is equal to log 3. So we divide both sides by log 2, okay? So that now the value of a is equal to log 3 divided by log 2. But now, log 3 divided by log 2, this is in the form of log a divided by log b, which we can express as log a to base b. So applying this property, then a is equal to log 3 to base 2. This is the value of a. So let's verify that this value of a actually satisfies the equation. Now let's verify that the value of a, which is actually equal to log 3 to base 2, actually satisfies the equation. Now again, if you recall, we end that 2 to the power a plus 4 to the power a plus 8 to the power a. This should give us a value of 39. Let's substitute the value of a. So we'll have 2 to the power log 3 to base 2 plus 4 raised to the power log 3 to base 2 plus 8 to the power log 3 to base 2. This should give us a value of 39. Let's check if this is true. Now, we can express 4 as 2 to the power 2, and we can express 8 as 2 to the power 3. Now here we'll have 2 to the power log 3 to base 2 plus 2 to the power 2 log 3 to base 2 plus 2 to the power 3 log 3 to base 2. This should give us a value of 39. Now, from here, we find that this is 2 to the power log 3 to base 2 plus, now 2 to the power, this is actually the power, so we can express this as 2 to the power log 3 squared to base 2 plus, now here you have 2 to the power 3, this is actually the power to 3 here, so we can express this as 2 to the power log 3 squared to base 2. This should give us a value of 39. Now the next step here, you find that 2 to the power log 3 to base 2, this is actually in the form of m raised to the power log a to base m, which essentially is supposed to give us a value of a. So that means that 2 to the power log 3 to base 2, this is equal to 3. Again, if we have 2 to the power log 3 squared to base 2, this is actually equal to 3 squared, which is equal to 9. Then we have 2 to the power log, this is 3, this is 3 to the power 3. This is 3 to the power 3. Okay, we have 2 to the power log 3 to the power 3 to base 2. This is equal to 3 to the power 3, which is 27. So now essentially here, we have that, essentially here, we have 2 to the power log 3 to base 2. This is equal to 3 plus 2 to the power log 3 squared to base 2. This is actually equal to 9 plus 2 to the power log 3 to power 3 to base 2. This is equal to 27. Okay, and therefore 3 plus 9, this is actually equal to 12. 12 plus 27, okay, this is equal to 39. And this proves that the value of a, which is log 3 to base 2, actually satisfies the equation. So kindly follow the steps, like this video, and subscribe. See you in the next video.